Hello everyone, welcome back to my additional maths class. For today's video teaching, I will focus on Form 4 topics. Many of the questions are very challenging, so I really hope that my sharing do help you to improve your additional maths, especially Form 4 syllabus. So let's get started with the class right now. Have fun! Firstly, let's read the question first. Diagram 3 shows the curve of a quadratic function. Point A and point B are on the curve. Point A is the y-intercept of the curve. So the important keywords you need to highlight so that you will start from the keywords. So point A and point B are on the curve. These 2 points are on the curve, and then point A is the y-intercept. So whenever you see y-intercept, always remind yourself must let x 0. So look at the curve. You have point A, alright, so you have point B. Now state the reason why the inverse function does not exist. Okay, now many students actually not really understand what the question wants. So I will explain to you. Now the inverse function will exist in a specific domain. Okay. Now let's study the graph. You have the quadratic function with the point A lies on y-axis and point B is given 4 and 6. So now the question is asking you, state the reason why the inverse function does not exist. So now let's revise back your previous function and relation lesson. So still remember when you study relation, you actually learn a type of relation, right? Okay, so you have how many type of relation? Okay, later we will go to type of relation. Now first step, you label the point A. Point A is 0, 6 first, is on the y-axis. Now, in order to answer the inverse function does not exist, I would like you to go back to your Form 4 or Form 2 syllabus. You recall the 4 types of relations. We have 4 types of relations. Number 1 is 1, 2, 1 relation. It means that one object has only one image, one x, one y for function. Okay, we have one to many. One to many meaning that one x will map to 2y. Okay, we have many to one. Many to one means many objects will map to one image. The many here refer to x values. And number 4 is many to many. Okay, now let's apply this concept to the graph or curve of function. So when you look at the graph, alright, you can actually read out the x value and the y value, right? So when you read the x, that is the object. When you read the y, that is the image. So in order to classify which one is function, so the one-to-one relation and many-to-one relation are function, because according to function, you must know that one object must has only one image, right? Then out of these 4, the only one that will have the inverse function, of course, will be one-to-one, because when you inverse back the 1 to 1, okay, is still mapped to one image, one object mapped to one image, right? So for the inverse axis is 1-to-1. Function is actually a 1-to-1 relation. So now let's go to the graph. Actually, you have learned the horizontal line test. So you can draw a line across the graph. Okay, when you see the line cutting at two point, that means it's actually many to one. Okay, if the horizontal line cut at only one point at the graph of the function, then it means it's 1-to-1. Still remember the horizontal line test for Form 4 KBSM student? So now for 1-to-1 inverse, okay, exists. Okay, so you must know that the inverse function is only exists for 1-to-1 relation. So let's see this graph or this function. Graph and function the same. Is it belongs to 1-to-1, one-to-many, or many-to-one, or many-to-many? Now, I would like you to take out the ruler and you try to draw the horizontal line test, and you will see that actually the curve, when you draw a line, it has 2 points of intersection, right? So you can use a horizontal line test to test. Okay, if it is cutting at 2 points, that means you have 2 intersection points, then the graph is belongs to many to one. Okay, many to one relation. So if it is many to one relation, now you see it's cutting at how many places? It looks like every line is cutting the graph at 2 points, isn't it? So we have 2 points. So it means that 2 objects will map to one image. So it also means that it is many to one relation. So when you see the cross that I put, it means that object, it means that the x value. So the x value will has one value of y. Both values of x will have one value of y. It means that both objects, that we have 2 objects, will have one image. So it is actually many to one. There are 2 intersections, okay, 2 points when you draw the horizontal line test. So we call as many to one relation. Alright, so I hope you understand how to use the horizontal line test. Now let's write down the answer. We need to answer accordingly. So the answer is no. Okay, the inverse function does not exist because this function is a many to one relation. Alright, so that is how you answer the question for A. Alright, so we have settled one of the hot question for function. Now we will proceed to the B, which is also very, very challenging. First of all, you need to understand the meaning of domain. So the inverse function will exist in a specific domain. State the domain. So the domain means the range of values of x. So now you need to divide the graph into 2 sides. Okay, one is we actually need to draw an axis of symmetry. So we divide by drawing we call as vertical line. So this vertical line will pass us through the maximum point so that it can divide the graph into two equal balanced sides. So I'm going to focus to these 2 points A and B. So the x value is labeled there 0 and 4, and I can find the midpoint. So with that midpoint, I can draw a line. I can actually draw a vertical line, and that vertical line is so-called axis of symmetry. Okay, so if you draw a line like green line like this, and it would for sure go through the maximum point, and that maximum point is the vertex of the quadratic function, and the axis of symmetry must always start with the x equal to the x value, which is x-intercept. So the axis of symmetry is x equal to 2, is the line that will cut or divide the graph into two symmetrical parts. Okay, so it must be always happen at the midpoint, and it must pass us through the maximum point if the quadratic function is having an a which is negative. So when the a is negative, it's always n-shaped, right? So now I will highlight the part whereby I have we so-called as the function that has only one object and one image. So for this part of the blue line, okay, is actually a function. Okay, it's a one-to-one relation. So the question is asking you the domain of the x is actually the corresponding x value for the blue graph. So I'm drawing the horizontal test to test whether it is a one-to-one relation. Yes, it is a function because one values of x will have one values of y. So it's one-to-one relation. So you can see the 1 point means you have one x and one y. So the horizontal test show you that only one intersection point. So this function is a one-to-one relation. And the most important keyword is domain. So as you can observe the blue curve there, the blue curve is actually the function with one-to-one relation. So we will actually highlight the corresponding values of x. Then that range of x is so-called as domain. So for this particular domain of x, you will have the one-to-one relation, which is function. Alright, understand? So for this part of the graph, the inverse is exists. Okay, the inverse function is exists for the graph that I highlighted in blue color, and it happens when the x is more than or equal to. So that is so-called domain of x. Understand? So you must understand the word domain means the corresponding range of the x that correspond to the blue curve. Now I'm going to draw another one, and I use a yellow color. For the yellow color curve, that part also you can say that is one-to-one relation, and it is a function, and you can see the corresponding domain is x less than equal to. So for this question, you can give either x more than equal to or x less than equal to, because for these two domain of x, the inverse function is exists, as you can see from the horizontal line test. Alright, so I really hope that you understand in depth so that you can answer the question confidently in the coming SPM exam. So when we talk about function, the range is always referred to the values of the y, and the range of x is always referred to domain of the values of x. So now the domain of the x, I must write x more than equal to. Alright, so domain is meant for x and range is meant for the y. Okay, I would like you to write the answer for dx more than equal to or x less than equal to for the specific domain of the x corresponding to the specific of the function. Okay, now for this question, diagram 4 show the graph function fx equal to modulus 2 minus 3x. Okay, the modulus is there. There are two lines where x starting from 0, more than 0 equal or less than equal p. So let's study carefully the modulus graph, and you must understand the concept of modulus. For additional maths, modulus is a very popular question in SPM exam. Now let's look at the modulus graph. Is always positive. The point given p and 11. So when you see the point p11, okay, the p is referring to x, and the 11 is actually referring to the fx, and fx is always y. Bear in mind that. So we can actually substitute the 11 into the function because 11 is the y value and y is equal to fx, right? So 11 is equal to modulus 2 minus 3p. So you need to substitute the p into the x. Alright, and then for fx, you need to substitute 11. Okay, so now when you solve the modulus, you must remember that you have to put plus and minus, right? So then you can solve the modulus, means you can throw away the modulus. So now you must split into two equations because you have two possible value of 11, which is plus and minus. So if I bring the 3p to the left, then will be 2 minus 11, which is negative 9. So my p is negative 3. So for p is negative 3, it seems like not related to the graph that given because all the x value are positive. So we can just reject the p equal to negative 3. Then how about if the 11 is negative? So we have to solve again. So negative 11 equal to 2 minus 3p. So negative 13 equal to negative 3p. And then the p is 13 over 3, right? So then you can say that the p value, okay, logically is positive 13 over 3, right? Okay, that is the value of the p that we obtain after we solve the modulus, and we choose a positive because the graph is having a positive x, right? Now we need to answer the question, find the value of p. Okay, state the domain again. Okay, when the range is greater than 2. Right, just now I just highlighted range means what? Okay, means y or fx. So meaning that when the y value is more than 2, what is the corresponding domain of the x? So we need to study the graph. Let's go to the graph and highlight the range which is greater than 2. Whenever you see the range is always referring to fx. more than 2, or you can say when y more than 2. So let's go to the graph and study y more than 2. Where is y more than 2? Okay, now you look at the function. You can write as y equal to modulus 2 minus 3x, right? Now we need to know where is the y equal to 2. Okay, isn't it is at the y-axis? Because if you letting the graph uh, y equal to modulus 2 minus 3x, if the x is 0, you will find the y, and that y is the y-intercept. So from there we know the y equal to 2 is actually at that line. Okay, so we are going to figure out y more than 2 is from where. Yeah, that is the green color showing that the y is more than 2 for the graph function. So we will write y more than 2. We need to focus to y more than 2. That is the green line that happened, or we can say the function that is having y more than 2. So now we need to highlight the range of the x. Okay, it's in purple color. This is so-called as corresponding domain. So the purple correspond to the green. Okay, so you have to read out the value there. Okay, we have 13 over 3, but we don't have the value for the x there. So we need to solve the modulus. So we need to substitute again the 2 into the modulus equation. So then we have to find the x, which is positive. Now let's solve it together. 2 minus 3x equal to plus minus 2. Because we solve the modulus, we must have a positive and negative 2. So 2 minus 3x equal to 2. So 2 minus 3x equal to negative 2. So let's solve it now. So we have the negative 3x equal to 2 minus 2 is 0. So yeah, x is equal to 0. So the other one is negative 3x equal to negative 4. So x is 4 over 3. So of course we will choose x is 4 over 3, right? Because it is actually more than 0. So that means the x, smaller value of x will be 4 over 3. And the bigger one will be 13 over 3. So we can write in a range from smaller to bigger. And the x, domain of x, it should be greater than 4 over 3 and less than equal 13 over 3. We must let the sign without equal for the 4 over 3, because for the corresponding y greater than 2, the question say greater than 2. It's not greater or equal to. So the x domain will follow x more than 4 over 3 and less than equal 13 over 3. And 13 over 3 can be equal because y is more than 2 is inclusive of the last point is inclusive of 13 over 3. Now this is so-called domain of the graph function. Okay, are you clear? So many students wonder how to do this kind of question, because maybe you not really understand the terms like domain is range of the x, and function means y, and the range means a y. So for y greater than 2, the x should be from 4 over 3 to 13 over 3, not inclusive of 4 over 3, but inclusive of 13 over 3. That means all the value of the x from 4 over 3 onwards to 13 over 3 will be accepted as the range of the x. So again, this is the answer for the question asking for domain. So domain for this question is x more than 4 over 3 and less than equal 13 over 3, right? Okay, so you need to state the answer in this form so that the question will be completely answered by you. Okay, so this is the answer for the domain. Okay, now we'll proceed to another question. For this question is about the score and the frequency, okay, for the marks. So find the maximum value of M if the mode score is 4. So if the mode score is 4, that means the highest frequency should be the mode. So you can see that the 12, okay, is the highest frequency. So that means the mode is 4. So the maximum value of M, if the mode score is 4, that means M minus 2, the frequency cannot be more than 12. So it should be less than 12 and the maximum is 11. So we can solve the M, which is equal to 13. So now for M minus 2 equal to 11, so M is 13. So we have solved that one. Now we are given the median, which is 3.5. So if you are given the median 3.5, that means the median is happening at between 3 and 4. So that means when you plus the 5 and 8 and n minus 2, it should be equal to 15. Then you can solve the m. Then the m is the answer. Alright, so let's solve the m. It's 5 plus 8 plus m minus 2 equal to 15. So you have 13 plus m minus 2 equal to 15. So m is 15 minus 11. So the m is 4, right? Okay, we have solved the statistic question, which is quite easy. Now let's proceed to the next one, which is actually the linear law. So you are given the graph log y plot against the x, and you have a straight line with the line cutting at the point -2. So this is a linear law. So now let's see how to solve this. So basically when you see linear law, you always start with the big Y and the big X, and then you can write down the big Y equal to mx plus c. Let me show you how to solve the linear law in order. So for linear law, we actually have the equation given. So if the power of the x is not 1, so the power here is actually showing that it is non-linear equation. So from the non-linear equation, we need to convert to a linear equation so that you can draw a straight line. So in order to draw the linear line or linear equation, we need to apply linear law. So what is so-called applied linear law is you look at the big Y, you are having log ky, right? So that is a big Y. And we have the big X, which is actually given small x. So from the nonlinear equation, you need to actually do something so that you can get the equation in y equal to mx plus c form. So now you need to make sure you follow the graph. The graph is having log base k. So we are taking log base ky both sides. So then you need to apply the law of logarithm. So it's log base k9 minus log base k hx. So remember when you minus, you just follow the law. So it's log k9 minus log k hx. Make sure you have two base log k for both terms, must have the base. Alright, when dy you must minus. Okay, so you have to apply the law. So the law say log x a over b, it must be log x a minus log x b. This is a law of logarithm. Okay, please follow the law and don't go against the law. Alright, so now we have applied the law already. Then we can apply another law, which is the power law. So according to the law of the logarithm, so we can bring the power to the in front. So still remember when you learn the law of logarithm, the power can always bring down and must be bring to the in front. This is so-called power law. So for power law, let's say we record the law. You have log ax with the power m. So m must be bring forward and multiply with the log ax. All right. So that is so-called apply the power law. So you have log ky equal to log k9 minus x log kh, right? So normally we will try to arrange in order until the equation in the shape of y is terms that consist of small y, and with the m must be a constant number, and followed by x, and we will have the plus with the constant. So that means log ky is the big Y, and log base k 9 is a c, and the x you have to bring to the right hand side. So the balance you have negative log kh is the constant we call as gradient, inclusive of the negative. So negative log base kh is the gradient, and the small x is the big X, and the c is log base k 9, so it's the c. So the big Y is log k with the small y. Okay, now then we go to the graph and we will find the y-intercept, which is the c, and then we will do comparison. We will equate them. So log base k9 is equal to c. Now you go to the graph. Have you noticed that the c is the y-intercept is -2? So then you can equate them. So log base k9 is -2. So then we can make the base the same like this. Log kk -2. Okay, or you can write as 9 equal to k to the power of -2 is the same. You can apply the law of the basic law. Okay, so 9 is k to the power of -2. So you have to be very careful. K power -2 you have to bring down, become 1 over k positive 2 equal to 9, and you cross multiply 9k squared equal to 1. So k squared is 1 over 9 square root. So you have two answers, right? So but you must not let the answer like this. You have to reject the negative answer, because the base of the any log should be always positive. Remember that. So the k should be 1 over 3, which is more than 0, because all the base must be positive number. Okay, that's about the linear law for the paper 1 question. So you must actually keep on practice so that you are good. Okay, so now we'll proceed to the next question, which is about the quadratic function again. So this topic is actually about the range of the values of x in terms of p and q. That is what you want to find. So for quadratic function, many students are very weak. So now I want to focus to this topic. Okay, basically when you see function, it's actually the graph with a y something equal to, normally is a quadratic function. So you can actually sketch out the function. When the a is positive, you will have happy, okay, face, and when the a is negative, you will have the sad face. So it looks like when you observe is x times x, so it's a positive function. So for quadratic function which is positive, you can sketch out the happy face, and then you label the y axis and label the x-axis, and label the most important is the x-intercept, because the x-intercept is the roots for the quadratic equation. So the question also mentioned the p and q, and the q is greater than p. So That means the Q will go to the right and the P will go to the left. Okay, so let's start with the quadratic function like this. If you don't understand, you can just use any number to represent P and Q. Alright, I just use the number to make you understand. Let's say that P is 2, the Q is 3, and the 3 is more than 2. According to the question, Q must be more than P. So it's something like this. That's the meaning of the question. And you notice that the x square, you multiply, you get a 1. 1 is positive, so you will have a happy face. So you can sketch out the happy face like this. And you label, of course, if you have the 2 and 3, you label 2 to the left and 3 to the right. But the question say P and Q, so you don't use a number. So the number is just for me to explain to you so that you understand. So when you label, you must label P and you must label Q. Alright? So the P is to the left and the Q should be to the right because it's a bigger number. And the function is more than 0. Of course, it will refer to all the y value which is above the x-axis. Okay, so can you see that I highlight in green color to show that that is actually the function which is y more than 0 or fx more than 0. Alright, so now we are going to read the range of the x. So the x should be more than q and x less than p. So this is the answer for the function which is greater than 0. Okay, for function which is less than 0, of course, you will highlight the path that will be below the x-axis, whereby all the y are negative. Y negative means fx less than 0. Okay, so you must understand the terms. So when fx less than 0, you're having the purple color function. With the purple color function, all the y there are negative. So it happened when the x from the where to where. So of course you can see the purple horizontal line there. The x should be start from 2 to 3, in between 2 to 3, right? So then you have to write the inequality for the x should be more than 2 and less than 3 when the function fx less than 0. It means y less than 0. It also means that fx less than 0. So normally if you don't understand, that is how you work out the answer. So for the upper part above the x-axis is fx more than 0. Below is fx less than 0. So it happened when your x from greater than p and less than q. So that's the answer for fx less than 0. So it's actually testing you all the concept. Alright. So this is a quadratic function again. Fx equal to negative x plus p square plus q. So for quadratic function, we have the vertex form. Okay, vertex form means you have the front is completing the square form plus the number q. So that's called vertex form, or we say completed the square form. So when you have the vertex form, you can read out the vertex. Vertex is the highest point for the graph. Okay, for the quadratic function, you can just write down negative p and q for the maximum point if the a is less than 0. And also you can read out the midpoint because you are given the u and the 3u, right? So the midpoint is always happening at the point that x coordinates is actually the turning point for the graph. So you have negative u plus 3u over 2. So u is the answer. So that equation, okay, you draw a line that divide the curve into two equal balanced sides. So it should actually go through the maximum point. So that vertical line is so-called as axis of symmetry. So for any axis of symmetry, it must go through the highest point. If the graph is happy and shape, if the graph is happy, it will go through the minimum point. If the graph is set, it will go through the maximum point. That is the axis of symmetry. So it's always x equal to the coordinate x of the turning point. Alright, so your x is equal to u is the axis of symmetry. And then you're asking to find the range of the x when the fx is equal to k has actually real roots. Okay, now I want to explain to you what it means by real roots. So you have to understand real root means what, then only you can do. Okay, so let's see. You are having the graph fx equal to negative x plus p squared plus q, and the point for the u given 2, so you have negative 2 and 6. So when you have negative 2 and 6, actually that are the two roots. Roots means is actually the x-intercept, so you can actually just use the two roots and form the equation. So we will actually try to substitute p equal to negative 2 plus 6. So you will have 6 minus 2, 4 divided by 2. So you get x equal to 2. So that means that p is equal to 2. So if you substitute into the equation negative x minus 2 square plus q equal to k, you will have problem because you don't have the value of k, right? So we don't have the value of the turning points for the y, so we cannot use this, we cannot substitute. So what you need to do is you form the equation, okay, using the two root, okay, negative x plus 2, okay, and then x minus 6, because you are given the 2 point, so you can form the equation, and the fx equal to k. Now you are in equation, okay, normal function, because the value of the function is given equal to k and has real root. Okay, now I need to explain to you what it means by real root. Okay, real root, it can mean that, example, you have the quadratic equation, you can solve the quadratic equation, and after you solve, you have the x values, right? So let's say the x is given, the root is given 2 and the other one is 2, that is so-called equal root, right? Then if you have the equation with the roots, which are, example, x equal to 4 and the other x equal to 4, so you can say they are equal root, right? Okay, so if you are having the quadratic equation and you solve, you got x equal to maybe 5, the other one is maybe 7, so you say different root, right? So for real root, it can mean that these two condition is either equal root or maybe different roots, so that is so-called real root. Okay, make sure you understand real root first before you proceed. Okay, understand real root? So normally for real root, you would use b squared minus 4ac more than equal 0. As I mentioned just now, it can be equal to 0 or more than 0. It can be two equal root or two different root. Alright? So remember that when you have the condition of real root, always use b squared minus 4ac more than equal 0. Okay, so I'm explaining to you again. When you have the equal root, is considered real root, and when you have the different root, example 2 and 3 here, or 3 and negative 4 here, you are saying that you have different root. So equal root or different root is considered real root. Alright? Okay, so I really want you to understand real root before you solve the equation. Now, based on this one, you can actually find the a, b, c, and then you substitute into b squared minus 4ac greater than or equal 0. Then you will try to get the answer. Okay, so that is so-called real root. Okay, now we go back to our question. The question that we have here is actually not general form, so we have to rearrange until general form. Then only we can read out the ABC. Okay, with the ABC, then only we can apply into the b squared minus 4ac. Alright, more than 0, more than equal 0. So you expand carefully. You expand inside the bracket first. So x squared minus 6x, okay, plus 2x minus 12. So we multiply the negative inside first. So it's negative x squared. So plus 6x minus 2x plus 12. Then we try to bring everything to the left so that we have the positive coefficient of the x squared. Coefficient of the x squared means a number in front of the x squared. So you will have something like this, which is in general form. So it's x squared minus 4x minus 12 plus k equal to 0. So you can read out your A is 1, B is negative 4, and C is negative 12 plus k, right? Then only you substitute into the discriminant b squared minus 4ac more than equal 0 for real root. So negative 4 squared minus 4k times 1, a is 1, and then b is negative 4, and c is should be negative 12 plus k, right? Now we need to substitute all the a, b, c into the discriminant, and then we need to solve it carefully so that we can get the range of the values of the k. So negative 4 square, okay, is a b, minus 4 times 1, 1 is a, c is negative 12 plus k more than equal 0. So we have negative 4 square is 16. Negative 4 times negative 12 is 48. Negative 4 times k is negative 4k more than equal 0. Okay, now I prefer to bring my 4k to the right hand side. So I will get 64 more than equal 4k. So I will divide by 4. I divide by 4 because I want to have the k alone. So I have 16 greater than equal k. So I will rewrite as k less than equal 16 is the final answer. Okay, settle. We have solved this question. And you notice that the question are very long-winded and very challenging because it comes with the basic of the concept of the quadratic function. Now let's proceed to another one, which is indices. Okay, you're given 2 power n equal to p and 3 power n equal to q. Express 3, there's a 3, that is a cube root, 27 power n plus 1 over 4 power n plus 1 in terms of p and q. So, okay, now by looking at what is given, 2 power n equal to p, 3 power n equal to q. So we need to modify the question until we can see what is given, 2n, 2 power n and 3 power n. Okay, now let's start with the cube root is 1 over 3. So when you see 27 is 3 power 3, right? 3 power 3 times n plus 1 times 1/3. Okay, so you have to multiply. Now let's see, we have 3 power 3 for 27, n plus 1 times 1/3. Okay, then divide 2, okay, power 2n plus 2 because the 4 is 2 power 2. So remember it's 2n plus 2, not 2n plus 1. Okay, this is the part many students will get wrong. It's 2 times n plus 1, alright, is 2 to the power of 2n plus 2. So now we almost get the pattern that almost the same with what is given. You are given 2n, 2 power n and 3 power n, right? So now we need to simplify further. We can cancel out the 3. Okay, so we are having 3 power n plus 1 over 2 power 2n plus 2. So remember what I say, for indices we have the law of indices. When you have AM, and you can write as A n times M. Okay, when you have 3n plus 1, you can write as 3n times 3. Okay, so when you have 2 to the power 2n, you can write 2 to the power n times 2. Now we just simplify. Okay, we can write as 3 power n times 3 power 1 over 2 n. Okay, then 2 times 2, 2, right? Okay, now we are applying the indices law reverse way. So now you can substitute the 3 power n as q. Alright, so we have 3q. Alright, so you look at the question, 3 power n is q. So now you can substitute 3 power n equal to q, and then 2n as p. So you will get the answer as shown in the answer scheme. So this question is about diagram 8 shows a straight line AB with the equation negative 3x over A plus 3y over B equal to 3, and the point A lies on the x-axis and the point B lies on the y-axis. So basically when you see the question like this, you have negative 3x over A plus 6y over B equal to 3. When you see x axis, there is a point that is so-called x-intercept, and the B is lies on y-axis. Okay, so that means you are given the y-intercept. So from the equation, you start with the finding the point A and point B first. So the point A lies on the x-axis. The moment you see x-axis, the y must be 0. The moment you see y-axis, the x must be 0. So we will substitute into the equation to find the x-intercept and y-intercept. Now I will copy down negative 3x over A plus 6y over B equal to 3. So I will substitute. Okay, I will make maybe x equal to 0 or maybe y equal to 0, depends on what you want to find. So if you letting y equal to 0, that means you are actually finding the x-intercept. So that means your y component will be 0. So negative 3x over A equal to 3. So your x is negative A, right? So that is the x-intercept. It looks like logic because you're having negative value. And then if you let just now you let y 0, now you let your x 0 in order to find the y-intercept. So now we will substitute the x0 into the equation. So we will get 6y. Okay, let me find a space to write the working to find the y-intercept. Okay, let's see how to find the y-intercept right now. So y-intercept can be found if you substitute x0, because the y-intercept is always having the x coordinates 0. So we will substitute the x0 into the equation. So our equation is negative 3x over A plus 6y over B equal to 3, right? So now 0, when you substitute 0, the negative 3 times 0 over A will be 0. So we try to solve the y. So that means 3b equal to 6y. So we are getting y is 3 over 6b, which is 1 over 2b, right? So with that you can actually try to solve the area of the triangle. The question is asking you to find the area of the triangle, right? So now you will
use a formula for the area of triangle, which is 1 over 2 times the base times the height, right? So we have 3 points. That is the base. Okay, the length of the base, it must be always positive. Remember, modulus or magnitude is always positive. So area for the triangle is 1 over 2 base times height. So it's 1 over 2 times the base is A and the height is 1 over 2B. So the answer for this question is AB over 4 is the area of the triangle. After we find all the points, finally we get the area for the triangle AOB is AB over 4. Right, that's the end of my lesson. I shall see you in my next video teaching. Bye.